The Air Force Small Business Innovation Research Program has funded many critical and commercially successful technologies. This is the story of one of them. In the early 2000s, the Air Force was looking for a better way to understand blast patterns in order to design missiles that could minimize collateral damage. To do that, they needed to measure the strains and deformations on the materials being used in today's defense industry. The traditional way to measure materials using a split Hopkinson bar and strain gauges couldn't produce the high-speed measurements that designers needed.
So a split Hopkinson bar is a 30-foot long bar, and you impact one side and the shock wave runs down the bar. By the time it finally hits the specimen, it's what's called a plane wave. So it's a perfect wave of energy going through the material, and it just rips the material apart. But it happens in 100 microseconds. This is not milliseconds, it's microseconds.
That's 100 millionths of a second. In 2005, John Tyson's company Trilion submitted a small business innovation research proposal for a paradigm-shifting approach to materials testing that integrated high-speed video cameras into the split Hopkinson bar test. The cameras capture what happens as the material is pulled apart.
The actual split Hopkinson bar work that we're doing is understanding the material properties so that they can design the missiles correctly.
Trilion's technology uses the deformation of applied dots to measure strains across any structure, regardless of material, shape, or size. The ultra-high-speed cameras records the deformation. Software converts those deformations into strain maps of the whole structure, identifying where future failures are likely to occur.
So after analyzing this part, we can see that this yellow spot right here on the corner is where it's going to be most prone to failure.
Trilion's novel approach is enabling and advancing better product designs as well as the incorporation of modern materials into the next generation of aerospace, medical, and even consumer products.
We've developed lots of different technologies to meet specific requirements. In the automotive industry, in auto crash, we do a lot of work in the auto crash world now, but this was all developed with Eglin Air Force Base. So we're applying this to automotive, aerospace. We do a lot in biomechanics.
Biomechanics is the study of the mechanical laws governing biological systems, such as the movement of the human body.
So this is a study of a hand, someone just wiggling their fingers. The colors on the hand correspond to the magnitude of the deformation. The blue streaks we see here correspond to areas of high compression. The reds and yellows correspond to areas of high tension. And the arrows are showing the direction of those forces.
Adidas just developed a new shoe, the Ultra Boost shoe, completely using our technology for studying the athletes, to studying the new materials, to studying the final designs on these athletes.
The work Trilion did under the Air Force SBIR has transformed the way research and materials is undertaken.
NASA uses this at every one of their major facilities for doing all kinds of different types of measurements. We've applied it to the Space Shuttle program. We're a small company, but we've had a major impact on these big companies.
The Trilion suite of 3D optical measurement technologies is expanding. In development is a virtual tooling system for the aerospace industry.
We want new products. We want products to go out there and improve the world. It's so important to me to see my products being used. And when products are being used, I'm a happy man.
The ultimate benefits of the SBIR program often ripple out in unexpected ways, as in the impressive case of Trilion, whose technology is helping improve everything from weapons to running shoes. Learn more at www.afsbirsttr.com.